One.
Hi, this is Steve Barton for Solid Rock Machine Shop Incorporated. Today I want to give a thank you for all of our subscribers, the people who have actually subscribed to our channel, and I want to give a thank you for those who have been commenting. The comments that you leave, they help us to know what we should focus on, and we have a lot of things that we can cover, but we want to be a benefit to the people that are viewing these videos. My son Adam was the one who first wanted to get into the YouTube videos, and he suggested it, and I kind of wasn't too keen on it. And after I started thinking a little bit, I thought, yeah, maybe these videos, that might be good, because I started looking at some on the YouTube, and there was some great stuff on there, there's some average stuff, and then there's a lot of really bad stuff out there. And so we thought we would try to contribute, and we're hoping that we can contribute to some of the stuff that might be of a higher quality and of benefit to others. Now, one of the things, anybody that's getting into the trade of machining, as you'll know, it seems like a lot of the good guys, people with the high skills, a lot of these people are retiring, and it seems like they're not being replaced as well, the people that are coming up in the ranks. And then there might be many reasons for that, and I'm not going to go in that, but I've been hearing for years that machining is a dying breed, and it's sad to me, because I tend to agree. I see a lot of people that are my age or older, they got this just tremendous amounts of knowledge, experience that they gained in a lifetime of machining, and as they go out of the trade, this stuff is not being passed down, in my opinion, the way it should. So I think YouTube is a great source where some of these guys, if we can get them on the channel and make videos and where they can pass down this stuff that they learned over the years, I think it'll be a great resource for people that are getting into the trade, or people that have been in the trade that just want to improve their game a little bit. So anyhow, that's our goals. And so when Adam was kind of pushing me to get in this, I'm glad he did. We're having a blast making these videos. It's a lot of fun, and if it is benefiting to any of you guys out there, that's just icing on the cake. So anyways, it was about a week ago or so, a few days ago, I was watching a video from a young man named Dave from Effenberg Knives. He is a custom knife maker. He makes some very high precision knives, some very nice knives, and that's a field that I don't have really any experience at all. And so watching his videos, it was kind of neat. I watched quite a few of them already. Just seeing what's all involved in making a quality folder knife. I was amazed. I was amazed at the tolerances that he was talking about that you have to maintain to achieve a quality knife and everything. But the one video I thought was kind of neat, he just bought himself a surface grinder, used one, and it came with a number of different wheels. And he was going to use that to grind his knife blanks, and he's wanting to remove a certain amount of material, he's wanting to achieve a certain finish on it. So those are some of the variables that he would have to control in order to get that. Well, the first wheel that he threw up, and he started surface grinding, he found out that he was leaving burn marks, the material wasn't coming off very good, and it wasn't a very good experience. And what I like about Dave is he didn't give up. That was that wheel, and I like the way he reasons. He went through his wheels, he found another wheel, and that was different. He put that on, and that wheel performed a lot better. It gave him better results. I don't know if it gave him the results that he was looking for, but it gave him much better results than the wheel he tried before that. And so, and this is what everybody needs to train their mind to work like his. He wanted to find out at that point, well, why did this wheel perform so much better than the first wheel? And so he starts out, and just by reasoning through things, he sees that there's numbers on these wheels. He's going to find out what these numbers mean. And those numbers on the wheel, they all have specific meaning. They tell you the makeup of the wheel. So I put a comment on his section, on his comment section, and told him that we've been focusing on surface grinding, and letting them know that we did a video on grinding wheels and surface finish, and that if he's interested, check it out. He might find a few points that might be helpful to him. And so he did, and right away he subscribed to the channel, and he gave us a great shout out, and we thank you for that, Dave. And because surface grinding was new, there was a lot of information. It was new to him. There was a lot of information on that particular video that he found quite helpful, and so that really makes us happy. So we have a new YouTube friend, and we're going to put a link to his channel if anybody's interested that's wanting to see what's involved in making a high quality custom knife. Check out his channel. And what I like is he will spend time and give you all the details of the things and the troubles that he's ran across and his fixes to it. So again, I like to see the way he reasons his way when he comes to a problem. The way he reasons his way through the stuff is really good. And you need that kind of mindset when you're in this trade. Dave, he could have just as easily, well, the surface grind don't work, tried the first wheel and just scrapped it. But he didn't. He stuck with it. And that's what we find is a lot of times if plan A don't work, go to plan B. If plan B don't work, go to plan. You keep throwing things out until you get the desired results. And sometimes you might not be able to get it, but a lot of times you will. So anyways, we want to talk about the variables that you need to control in surface grinding to get the desired results in the project that you're working on. And so some of the variables that you may, or I should say, the end results you might want. If you have something, it may be a plate, one of the outcomes that you might want is you might just want this thing to have a super good surface finish. You don't care about the thickness, you don't care about the flatness, you just want it to have a good surface. Well, you're going to use it and focus on a different set of variables to achieve that than you would if you have a plate like this or a V-block where you're going to hold the thickness to plus or minus a couple 10,000ths, where you're going to hold the flatness and parallelousness. In other words, you can have this flat, so it's flat, but it could have a bow, so you want it parallel and flat. You got a different set of variables that you need to focus on. And so you have your finish as a set of variables, your flatness, that will have another set of variables, and the size. And a lot of times in a project you might want a combination of all of those different outcomes that you want in your project will determine the variables that you need to control. And so what are some of the variables when it comes to surface grinding? You can take your wheel alone, and this is what Dave found out in his video. The wheel alone made a huge difference in the outcome that he was trying to achieve. You have aluminum oxide wheels, you got silicon carbide wheels, you got super abrasive, you got CBN wheels, you got diamond wheels, and it goes on and on. And in all of these wheels, they have different bonding agents, different bonding materials, different bonding hardnesses. They have different, you got ruby wheels that I, kind of new to me that I like. You have the closed structure and the open structure. All of these things will play a big effect in the outcome of the project you're doing. And one of the things that is a huge variable is, and we're going to go to our surface grinder here in a minute and show you, but one of the things that's a huge variable is your coolant. There's so many different coolants out there. You have water soluble oils, you got synthetics, you got semi-synthetic. There's so many of these, and they all perform a little different. They got their pros and cons. The mixture, how you mix it, is important. Everything about the coolant. If it's dirty coolant, in our case, we have to change our coolant because it's quite dirty. If you've been following some of the videos that we've been doing, we've done a number of videos where we're doing these precision bent stones that Robin Rensetti, he's got an excellent video that turned us onto these, and those videos that we were grinding that, we have in the comment section, we have a link to his channel where you can see all you need to know about these stones. But in order to get these stones, to get them flat, we had to use a diamond wheel, and we had to get that diamond wheel dressed. In order to get that diamond wheel dressed and true, we use these aluminum oxide sticks. They're very soft bonding material, an A. These are 8 inches long, 1 inch square. And we use 2 or 3 of these sticks trying to true that diamond up. And we have a video on that you can see where we talk about that. But by using these sticks in our coolant, now we got all these sticks that are ground down, and you got all these particles that are coming from the sticks. We did 5 different sets of these blocks. There's 2 in a set, so 10 of these blocks where we're grinding, and we're grinding an average of about 10 to 15 thousandths off all the sides. And so we have all the grit in our coolant now from these stones as well as these dressing sticks. And Adam is going to post a picture that he took earlier showing you in our coolant tank just the mess that's leaving in there. And so what we're going to do today, we're going to clean the coolant tank, because if I grind with that coolant right now, I can see the grit all over the table that's coming on there. And if you're grinding something and you're wanting to hold size and flatness, and your wheel comes down and your coolant shooting another grit of a different size in there, your finish is going to be bad, your size, you're not going to be holding accuracy. You just need to get that coolant changed. I have a cheap coolant system. It doesn't have a high-tech filtering system. It doesn't have a magnetic separator or a paper filter system. So we'll have to clean it a little bit more often. So if you come over to the surface grinder, we'll just show you what we're going to do here. One of the things that you want to do is, if a lot of times you have a lot of that garbage sitting over here. One of the things people will do, they'll wash this down into their coolant tank. Now if you got a good filtration system on there, that'd be okay. But really what you have to do is let the stuff dry out and take a nice plastic scraper and scrape as much of that stuff out as you can and dispose of it, rather than let it get in your coolant tank and contaminate your coolant. What we're going to do over here, because we got some residue material, not a lot, and because we're going to be changing the coolant, I'm going to go ahead and wash what little bit I have left in here. We're going to wash it in the tank, and then we're going to clean the tank out. And when we clean the tank out, we'll do that offline, and then we'll come back. But for right now, I'm going to just I unhook the hose over here. That way I can hold it nice and straight, turn the coolant on, and I'm just going to wash this out a little bit and get some of that stuff down in the tank so we can clean it later. We're going to mute the noise when I turn this on, because our coolant tank, it's a cheap one. The motor we have makes a lot of noise. It's an irritating noise. Hopefully in the future we're going to get us a good 3-phase pump that'll be a lot quieter. So we're going to mute the noise as I do this, and then we're going to go ahead and we're going to clean the tank out, and then we're going to come back and finish up the videos. We now have the coolant tank cleaned out, and so now what we're going to do is we're going to mix the coolant. We filled this bucket. We have about 3 gallons of water in there right now. The water we're using is distilled water. One of the things that I found out by looking on the internet, that the distilled water, because it didn't have the impurities that well water has in it, would keep the coolant fresh longer. It wouldn't get that rotten egg smell from that bacteria growth. So I thought I would try that. Another thing that we did, Jonathan, who you've seen on some of the videos, we want to keep that coolant aerated, and so we use this little fish tank aerator that he suggested. It worked out great. We can keep the coolant aerated with that. A lot of shops, they'll just run the air line off the air compressor, and they'll have a valve on there, and then they let the air tank from the air compressor supply the air for bubbling and keeping the coolant moving. But that can get expensive running that. You can run that all year long for pennies, and so that actually worked pretty good. This is the first time that I used water-soluble oil coolant, where I've actually had this coolant in there for over a year. I had it setting for, I bet, 2 to 3 months at a time, and did not have a bacterial growth in it. That coolant smells as fresh as the day I put it in. The reason we're changing it is what was mentioned at the beginning of the video. We just had too much solids in there from from the work we use. So I love it. Before, when we're using our well water, we'd have to change this coolant about once every month or so because it would get that bacterial growth and it would get real smelly. Now we don't have to change it until it gets contaminated with particles. So one thing that you want to do is you want to mix the coolant in the water. We got the pail about 3 gallons filled with water, not all the way up. We're just going to take this cordless drill. We're going to take a paint mixer. That's what we're going to get the water stirred up with in the coolant. And so as I got this going in there, Michael's going to pour that in there. He's going to just slowly pour it in. We'll go a little faster than that. Okay, now if you want to grab this and go ahead and top her off. Yeah, go ahead and pour some more in there. Okay. And what we're using is a mixture of 20-to-1 is what they recommend. Different coolants may have a different mix ratio. And the mix ratio is important because it could, if your coolant's too thick, it can affect the grind. If it's too thin, it could affect the grind. Other thing is if it's too thin, a lot of times you'll start seeing rust develop on the different parts that you come off the grinder. Also, as mentioned earlier, there's different types of coolant. You got your soluble oil, you have your synthetic, your semi-synthetic, and they all have different properties. I'm going to post some links from from this coolant that we're using, SimCool, on the mixing procedures. They'll tell you why you want to mix the coolant in the water, not the other way around. They'll give you some important tips. The other thing, you notice we have this sitting out here all the time. We usually keep it full of distilled water. That's what we're using. If you use hard water, shitty water, you got chemicals and contaminants that are in there that you just don't want to have in your coolant anyhow. So we keep this out here, and the reason we do is because we want it to have about the same temperature. We want it to be stabilized as a room temperature. If we take water that's probably just freshly distilled, sometimes that's quite warm. And if you're wanting to do some surface grinding after you mix the coolant, and your coolant happens to be warm, you're going to have some trouble with the thermal. This way everything's stabilized temperature wise. I'm going to pour this in our tank right now, and we'll see how full it will get it. We may have to add some more. Yeah, and I think we're going to need a few more gallons in there, so let's pour about half this jar. Okay.
jar probably is over half full of it, Michael. Probably about 5/8, 3/4. We'll go about 3 gallons.
Okay. Go ahead and start mixing in there. Slowly. Okay, we'll just leave it right like this. What we have, if you can see it, we have different baffles in this tank, and I want to keep it lower in the baffle so that can actually trap the different loose particles in each chamber there. So we'll just leave this. When we run a little low on coolant, we'll just got some premix that we can add. What we have to do now is put the top on. One of the last things that you want to do before you hook your hose back up is within the pump and within the line you may have some old coolant, and especially if you have to change it because it's sour and has a lot of bacteria, you want to get all of this stuff cleaned out of your system. You don't want to reintroduce, if you can help it, don't want to reintroduce any bacteria whatsoever. So what we'll do is we'll just take this bucket that we used to drain some stuff, and we'll turn this on and we'll pump out some of the coolant. Just to make sure that we have the lines cleaned out now too. And at this point, all we have to do is hook this line back up, hook the aerator back in there, and we leave that running all the time. And what we're going to do after this on a separate video, you can see the top of this chuck. I got it all inked up. What we're going to do, one of the best times to regrind your magnet if it needs it is right after you change your coolant, if the coolant is the same temperature. The reason why is because you want this magnet to come out nice and flat. You don't want any contaminants messing things up. Your work is only going to come out as good as what your magnet is, unless you employ some other tricks, which you can. We'll go over that in the future. But generally, you're only going to get your work as flat as your magnet is. And so what we're going to do in the next video, we're gonna grind the magnet. I get this inked up so I can see my high and low spots. I think my magnet's in pretty good shape. I don't think it's really necessary to grind it, but because we do put fresh coolant in there, I wanted to go over this. There's a lot of YouTube videos on grinding the magnet. Some are better than others, and I thought we would just add what we do too and see if that's a help to you guys. Well, we'll see you next time.